Okay, today we're talking about trigonometry, which is the study of the relationships between the sides of a triangle and the angles of a triangle. And so I'm going to introduce you to three terms: sine, cosine, and tangent. And so the first one we're actually going to talk about them all at the same time. I'm going to teach you SO, ca, toa. So say it with me, SOHCAHTOA. This is how you're going to remember how all of these formulas are put together. There's three formulas here: sine, cosine, and tangent. And sine is the opposite side over the hypotenuse. Do you remember that the longest side is always the hypotenuse? That's just always the way it is. We call that a special name so that we can differentiate it from the legs. And so sine is opposite over hypotenuse. And then cosine, okay, is adjacent over hypotenuse. So adjacent, ADJ, over hypotenuse. Okay, again, the hypotenuse is the longest side. Opposite and adjacent, I'm going to talk about, they change depending on your perspective, which angle you're speaking about. So tangent is going to be the opposite side over the adjacent. So opposite over adjacent. Okay, so now if I'm talking about angle A here in this diagram, let's say I'm talking about angle A, then from that perspective, A, this little a right here, you see this? That is the opposite side. And it turns out that if I'm talking about this angle A right here, then this is the adjacent side. The adjacent side means what is right next to it, right? So adjacent is right next to A, and opposite is across from A. It's pretty logical. And hypotenuse is always hypotenuse. The hypotenuse never changes. It doesn't depend on your perspective. It's just always the longest side. So in this case, okay, with respect to this diagram right here, and with respect to this angle A, if I wanted to define sine, sine would be opposite over hypotenuse. So it would be the side A, right, over the side C. Okay, and now we're going to go to cosine. With regard to cosine, if we're talking about the angle A, then cosine is adjacent over hypotenuse, which means B over C. Okay, and then again, with regard to tangent, if I'm talking about this angle right here, angle A, then that is opposite over adjacent. So that would be the A side over the B side. So you can see how these relationships begin to take shape. We're just going to use them enough that you're going to memorize all of these. So you're going to be able to come up with them off the top of your head. So with regard to number one, let's take a look at this problem. If we have these side lengths are all listed for us here, we're going to take a whack at saying, what is sine of A? Well, if you go to the angle A and you think about from this perspective, let's label the triangle. Adjacent, right? That's the side right next to it. This is the hypotenuse. That's the longest side. It's always the hypotenuse, no matter what. And this is the opposite side from the perspective of angle A. And so the sine is opposite over hypotenuse. Opposite over hypotenuse. So that would mean sine A is 5 over 13. Okay, let's try cosine A. So cosine A, we don't have to change the way we've labeled it because we're still talking about angle A, right? So as long as we're talking about angle A, we don't have to change the way we label it. But we're talking about cosine, which is adjacent and over the hypotenuse, adjacent over hypotenuse. So that's going to be 12 over 13, the adjacent side over the hypotenuse. All right. So then tan A, what's the tangent of A? The tangent of A would be the opposite side over the adjacent side. And so that would be the adjacent side, right, which is, the opposite side, 5, over the adjacent side, 12. So that's going to be 5 over 12. So far, so good? So let's talk about how we could use this to solve a problem. So in this case, if you're looking at number 3 here, my problem is that I don't know what x is. So I'm obviously looking for this side length. And I do know what this angle is. It's given to me as 28. So I can say that from the perspective of this angle right here, I'm going to label this triangle. I'm going to say this is the adjacent side, this is the opposite side, and this is the hypotenuse. Obviously, using one with an adjacent side would not do me any good because it couldn't help me find what I'm missing. I'm missing the opposite side, and the adjacent side is not labeled. So that's not going to be very helpful, is it? So what I need to do then is pick, for example, so. So has opposite and hypotenuse in it, and that's what I've got as labeled, right? So sine of 28 in this case is equal to the opposite, which is x, over 19. All right, so I've got the sine of 28 is equal to x over 19. And so let's work number 4 as well. So for number 4, in this case, I've got this angle labeled, so I'm going to go from this perspective and I'm going to label the triangle like this: adjacent, hypotenuse, and the opposite side. So now I'm going to set up a formula where the adjacent side and the opposite are both involved. So that would be TOA, right? That has the opposite side and the adjacent side. So that's going to be like this: the tan of 41 degrees, that's equal to the opposite side, x, over 32. All right, and then we're just going to keep going. I'm going to keep cracking on here. So for number 5, with respect to this angle, 21, which is listed, right, it's labeled, I'm going to label this triangle like this. This is the hypotenuse. That's the longest side. It's opposite from the 90. So that's always going to be the longest side. So this is going to be the adjacent side, and this one is going to be the opposite side. So I need something that has adjacent and hypotenuse in it, which would be ca, right? The cosine of 21 degrees is going to be adjacent over hypotenuse. So it would be x over 26. All right, and then finally number 6. Let's take a look at that one. Number 6, this is the angle listed, or labeled, and this is the hypotenuse. That's the longest side, the one opposite from the 90-degree angle. And then this is the opposite side. So what I need is a ratio that's going to include the opposite and the hypotenuse, which again is so, right? We can use sine. So sine of 33 is the opposite side, 15, over the hypotenuse, x.